We are going to find the area of this triangle by using this formula here. This formula assumes that one of the coordinates of the triangle is at the origin, and the other 2 points are called x1, y1 and x2, y2. So we can't apply this formula directly to this triangle. We have to move this triangle. We have to move one of the corners to the origin. So what I will do is I will move the point minus 6, 2 to the origin. So how do we move minus 6, 2 to 0, 0? What happens to minus 6, 2 as it's moved towards 0, 0? Well, you can see that we'll have to move this point down 2 units, and we'll have to move it to the right by 6 units. So I'm going to use the diagram to translate this triangle. So this arrow represents the translation. Minus 6, 2 goes to 0, 0. So we need to move A and C under this translation. So we need to move A down 2 units and to the right by 6 units. So A is going to end up here. So let's read off the coordinates of this point. Well, we've decreased A by 2. So the y value of A was 5. So we decrease 5 by 2, we get 3. The x value is increased by 6 units. 3 plus 6 is 9. So you see we're out 9 and up 3. We can just read it off here. Each of these squares is 1 unit. So we do the same to this point. We just go down 2 units and we go across 6 units. So what are the coordinates of this point here? Well, we can just read them off, or working with these values. The x value of point C is increased by 6. 6 plus 4 is 10. The y value minus 4 is decreased by 2 units. We go down 2 units, so we're down at minus 6. So we have this new triangle, this green triangle. One of its coordinates is at the origin. So we can apply this formula. This formula involves 2 points called x1, y1 and x2, y2. So we can call one of the points x1, y1 and the other point x2, y2. So I will call this one x1, y1. Doesn't matter, of course. And I will call this one here x2, y2. So now we can get the area. I'll write A for area. It's a half the magnitude of x1 multiplied by y2. Well, x1 is 9, y2 is minus 6. So we have 9 times minus 6. Then we have a minus sign. We have minus sign here. Then we have x2 times y1. x2 is 10. Y1 is 3. So the area is half the magnitude of minus 54 minus 30. So you have half the magnitude of minus 80. Sorry, minus 84. Well, when you get the magnitude of a quantity, we just make it positive. So we just have half of 84, which is 42. So our answer is 42 square units. Now what's a square unit? The square unit is the area of a square of side 1 unit. So each of these marks here is a unit. So a square of side 1 unit would be, for example, this square here. So each side of this square is 1 unit. The area is 1 times 1, which is 1. So there are 42 of these squares inside this green triangle, or inside the red triangle. Of course, both triangles have the same area. Now, of course, we can do this question without drawing this diagram. If we were just given the 3 points without any diagram, we could work out the coordinates of the translated triangle, of the corners of the translated triangle, by just looking at the values here. To go from minus 6 to 0, we have to add on 6. So we just add 6 onto the x values. Minus 6 plus 6 gives us 0. So 3 plus 6 is 9. Then we have 4 plus 6 here. 4 plus 6 is 10. So we have the x values of our points. Now to get the y values, we look to see what the difference is between this number and this number. So we have 0 minus 2. Well, that's just minus 2. In other words, 2 minus 2 gives us 0. So we have to subtract 2 from 5. 5 minus 2 gives us 3. Or sorry, yeah, 3. And similarly here, we've minus 4 minus 2. That gives us minus 6. So then we label one of these points x1, y1, and the other point x2, y2. And without any diagram, we can plug these values into our formula, which is up here, and get the area of the triangle.